Hello learners and welcome to your Natural Sciences lesson. So join me today as we answer questions or practice questions and application questions that are based on the non-contact forces and the contact forces. Remember, the non-contact forces are sometimes referred to as the field forces. So our first question, it says, what is meant by magnetic force? So we need to know that this comes from the word magnet. Remember, we have a magnet that can either have a north and a south, and the space around the magnet, the space in which this magnet is going to experience a force, that space is called your magnetic field. So what is then meant by the magnetic force? So the magnetic force that's a force of attraction or repulsion. So that means this magnetic force can either be an attractive force or a repulsive force. So it's a force of attraction between the poles of the magnet, or we can define it as the force by which magnetic substances are attracted towards the magnet. Now remember, the magnetic substances, those are the substances that can be attracted to the magnet. And the non-magnetic substances would be the substances that will not be attracted to the magnet. So that's the difference between the magnetic and the non-magnetic substances. Now question 2, it says, is magnetic force attractive or repulsive or even both? Now by definition, remember we said that's now a force of attraction or repulsion. So which then means that our magnetic force can be both attractive or a repulsive force. So therefore, the magnetic force is both, it's both attractive and repulsive force. Now, next question. We are then supposed to, or we are given that forces are classified into two main groups. Remember, we said we have the contact forces and the non-contact forces, or we can refer to them as your field forces. So the forces can either be contact or field forces, or we can say contact and non-contact forces. So question is, in which category does magnetic force fall? Now, the difference between the contact and the field forces is that with the contact forces, the two objects that are interacting are going to be applying a force onto each other. However, those two objects, they must be in contact. So those two objects that are exerting a force onto each other, they must be in contact. But with the field forces, yes, the two objects can still exert a force onto each other, but those two forces or those two objects, they don't have to be in contact or even touching each other. So that means they can exert a force at a distance, so which is said to be action at a distance. So this object A and object B. So object A can exert a force onto object B over a distance. It can attract object B over a distance. For instance, if you take a magnet, if you take a piece of magnet and you put a piece of iron next to it, now this magnet is going to pull towards itself. It's going to pull this piece of iron to it. So basically it is going to attract that iron to it. So that force of attraction was applied over a distance. This magnet didn't have to touch the iron. So we are then saying that the magnetic force falls under the non-contact forces, because those are the forces that are acting over or at a distance. So in which category does that fall? It falls under, we can say, the field forces, or we can say the non-contact forces. Then question 2, what is meant by magnetic substances? So magnetic substances, as we have said, we can either have the magnetic substances or the non-magnetic substances. Magnetic substances are substances that can a magnet. So the magnetic substances, those are the substances that can be attracted to a magnet. And they can also be repelled by the magnet. Now, question C. It says now we need to name 3 metals that are magnetic substances. So 3 metals that are magnetic substances as an example. So we can choose the following metals. We can have iron, we can have nickel, and we can have aluminum. Now remember, because we are science learners, we should know what the symbols of these metals are. So iron has a symbol Fe, capital letter F and small letter E, and then nickel, capital letter N and small letter I, and then aluminum, A and small letter L. And remember, we're finding all of these metals in a periodic table. So you can find all of these metals in a periodic table. And these substances, they are magnetic because if you were to place them closer to a magnet, they would be attracted to the magnet. So a magnet would be able to pull them, remember, over a distance. They don't have to be touching each other. Now the next question now says, what does the mass of an object indicate? Remember, we said there's a difference between mass and weight. Mass is the amount of substance or the amount of matter that makes up an object or a substance, that makes up a substance. For instance, if you are told that your weight is 30 kilograms, or not your weight, your mass is 30 kilograms, that's just the amount of matter that are making up you as a body. It has a mass of 30 kilograms. But with the weight depends on the gravitational due to the acceleration due to gravity. So your weight depends on the acceleration due to gravity, meaning that if we are saying that your mass is 10 kilograms, or an object has a mass of 10 kilograms, its weight is not going to be 10 kilograms, but then its weight is going to be calculated by multiplying the mass and the acceleration due to gravity. And this is equals to 9,8. So that then means this is going to be 10 multiplied by 9,8. And this is going to be 98. So the weight of this object that has a mass of 10 kilograms is going to be 98. But weight is a force, and therefore it is measured in newtons. So the weight is 98 newtons, but then the mass of the object is 10 kilograms. So there's a difference between mass and weight. Mass is the amount of matter making up a substance, but then the weight depends on gravity. So it depends on where you are on this universe. If you are in the moon, if you're on the moon, your weight there is going to be different as compared to when you're here on Earth, because the gravity there is different from the gravity that we have here on Earth. Question 5 says, which SI unit is used to indicate the mass of an object? So remember that we can measure mass in many different units. However, the SI unit, the standard unit that we use to measure the weight, needs to be kilograms. So whichever weight that we are given, it must always, before we can do any calculations with it, it needs to be converted to kilograms. If we are given a weight in, the mass in grams, we need to convert those grams into kilograms. If we are given the weight, the mass in any other unit, it needs to be converted to kilograms. Right. So before we move on to the next part of the questions, being the application questions, we're just going to quickly go for a short break, and I will see you just after this.